You want to go over the last one? Don't figure it out. Logan, you figure it out. You try it. Okay. Yeah, let's do it. All right. So number what is that? 26, right? Yeah. So we have the sine of theta times cotangent theta plus tangent theta equal secant theta. So your first step, you have two options. You can either go ahead and distribute, or you can replace these first and then distribute. Let's just go ahead and distribute to start. So we'll distribute that into both. We get sine theta cotan theta plus sine theta tan theta equals secant theta. So next, we need to try to condense this somehow. So we can replace cotan and tan with their sine cosine equivalents. Cotan is equivalent to cosine over sine. Cosine theta over sine theta. Replace that. And tangent is sine over cosine. Sine theta times sine theta over cosine. See that we get one cancellation here because these are opposites, so it comes off. Then we're left with cosine theta plus sine times sine does not cancel, unfortunately. It's sine squared theta with cosine. Tracking so far? Okay, now what we want to do is try to combine these two fractions together. In order to do that, we need a common denominator. This one just has a denominator of 1 right now, so we're going to multiply it by this other denominator over itself. So times it by cosine over cosine. We then get cosine squared over cosine plus sine squared over cosine. Again. Now, since they're the same denominator, we can go ahead and combine those. Just add the numerators, keep the denominator. Cosine squared plus sine squared over cosine equals secant. Then we have our Pythagorean identity. Cosine squared and sine squared give you 1. So we have 1 over cosine equals secant. And then 1 over cosine is equivalent to secant. So secant equals secant. It's like the longest one that we'll have, even longer than the ones today as well. So if you get that, you'll be good shape. I did kind of show you the steps on how to do that. Were there any other ones anybody want to see? Today we're just going to go through a few more, and then you'll have class time to work on some as well. But we'll do a few examples here together. So let's start where I picked here. All right, we're going to start with this one. This one, they're just going to switch up the variable on you and do the problem. So we're going to use a u instead of a thing. And we're going to be using the Pythagorean identities mostly today. All right, so we got tan u cotan u minus cosine squared equals sine squared. I always want to kind of think a little bit ahead too. So if we're going to solve this, eventually we're trying to get it equal to sine squared. So what do you think this first part should be at some point? 1, yeah, it should eventually be 1 probably, right? Because then if we had 1 minus cosine squared, that would equal sine squared, right? So let's not touch this cosine squared. Let's just see if we can maybe get that to be 1 somehow. We can change the tans and cotans into either sines and cosines. There's actually 2 things you can do on this one. You can do either or. You guys want to change this into sines and cosines or something else? Cosine and cosines. Tangent is sine u over cosine u. Cotangent is the opposite. Cosine u over sine u. Minus cosine squared u equals sine squared. Now these are both opposite canceling here. So we're left just 1. It's not a 0, it's 1. This is just kind of a 1 place over there. So it becomes 1 minus cosine squared u equals sine squared u. And this is one of our Pythagorean identities. It's not necessarily written this way on our formulas, but it's written like this: sine squared u plus cosine squared equals 1. If you just rearrange that, if you just subtract the cosine, then it's obviously cosine, right? So then we go ahead and write sine squared equals sine squared. There's actually a different substitution you could have made, which kind of shows you that there isn't always one correct answer. There's different ways you can do this. You could have, if you wanted to, you could just have left tan u by itself, and then substituted for cotan u, you could just do 1 over tan u. That's another one of our identities, right? Because then that would have canceled under just 1. So either one of those would have been fine. Yeah. All right, let's try a few more. Secant theta minus 1 times secant theta plus 1 equals tan squared. All right, what should we do to start this one? Do you want to substitute or do something else? Is it just right for the weekend? We don't want to substitute right off the bat. If we did, like, change out secant to be 1 over cosine, then it's just going to kind of get messier at that point. What you do want to do is you got to FOIL this. You got 2 binomials, right? And also think there is a trig identity that has tan squared in it, right? And it's the one with secant squared in it. So when we FOIL this, we're going to get a secant squared, so it kind of seems like we're on the right track there, right? So secant times secant is secant squared. Yeah. So then have our outer, secant times 1 would just be secant plus secant theta. Negative 1 times secant theta would just be minus secant theta. And then minus 1 plus 1 minus 1 equals secant squared. You do need to make sure you're showing your work on this because again, that's kind of what we're doing. We're just showing the work how we get it to equal tan squared. So show that you're writing these middle terms even if you know they're going to cancel. Then we can see they do cancel, plus and a minus secant. Then we get secant squared theta minus 1 equals tan squared theta. And we have an identity for this because if we look back at our identities, our Pythagorean identities, we had tan squared plus 1 equals secant squared. So if we just rearrange this, if we just subtract the 1 over, tan squared is secant squared minus 1, which is what we have. So we're allowed to just go and use that one. And up here. So then we just have tan squared equals This is actually not a different question, sorry. Okay, let's try a few more like that. Try this one. Secant theta plus tan theta times secant theta minus tan theta. So we're going to want to FOIL this again, right? We're going to secant times secant to start. That gives us secant squared. Our outer is going to be a minus secant tan. Our inner is going to be a plus. It's written as tan times secant, but you can just write it as secant tan. You can change the order there. And then last will be a minus tan squared equals 1. So again, we get a nice cancellation there. Boom, boom. Secant squared theta minus tan squared theta is 1. Now what? What is secant squared theta minus tan squared theta equal? Could we make that equal to 1? Tan squared plus secant squared. You can just rearrange this as actually the same thing, right? You just do 1 equals secant squared times tan squared. So actually, it's already good. We're just going to write 1 equals 1. So these three formulas, you're going to have to be able to rearrange them a lot. Not always going to be written in the way that you want it to, but they're really helpful. Generally, they're going to be what you want. So then we got 1 equals 1. We're good. Got 2 more here. All right, what do we want to do here? Because we'll distribute first. Substitute. What do they? Distribute. Yeah, for that. So cosine squared times 1 will be cosine squared plus cosine squared times tan squared will just be cosine squared tan squared equals 1. All right. Now what should we do? One to our place. Okay, what do you want to place tan squared with? Good, yeah. So, although this isn't one of our identities, we know this to be true. Tan squared is equivalent to, well, sine over cosine is tan. So for tan squared, we can make a sine squared over cosine squared. That works. It works. So where it says cosine squared theta plus cosine squared theta times sine squared theta over cosine squared theta. So we're allowed to do that. We can square each of these individually and it'll be the same as this. Okay. Then we get a nice cancellation there. And we're left with cosine squared plus sine squared equals 1. And that actually is the identity, right? Sine squared plus cosine squared, so we're at 43. All right, last one, and then you guys can do some on your own. Hopefully you're getting pretty comfortable with how to do these at this point. This one's a little bit longer, but so we got sine theta plus cosine theta whole quantity squared plus sine theta minus cosine theta whole quantity squared equals 2. All right, so what do we need to do with these things? Is this sine squared plus cosine squared? It's not. No, we gotta FOIL those extra. Because sine plus cosine, it would be the same thing as sine theta plus cosine theta times sine theta plus cosine theta. So this is actually twice because it's the whole thing is squared. So you've actually got to FOIL this, and then you got to do the same thing with the negatives over there. Take a little bit of shortcut as we do it. But let's go ahead and do this. So sine times sine is sine squared. Outer sine times cosine, so sine cosine. The inner is going to be the same term, right? Sine times cosine, cosine times sine, same term. So let's write it as plus 2. We'll just go ahead and group those. 2 sine theta cosine theta. And then we got plus cosine squared. And then this one's going to be the same thing, except it's a minus sign. So plus, we'll have a sine times a sine, so it'll be sine squared. Our outer and our inner are going to be the same. They're going to be minus sine cosines. It's going to be minus 2 sine theta cosine theta. And our last will become a plus. Plus cosine squared theta equals 2. And hope as we get some cancellations here. We got a plus 2 sine cosine, minus 2 sine cosine. We have 2 sine squareds. So we can write that as 2 sine squared theta and 2 cosine squareds. So plus 2 cosine squared theta. Now, yeah. Yeah, so sine squared plus cosine squared, that's right. So what we can do is we can just try it this way, pull out the 2 since I'm going to share 2. Show that we're using this identity. 2 times sine squared plus cosine squared. Like that way. And then we'll just put in 1 right there. The sine squared plus cosine squared is 1. So 2 times 1 is 2. And 2. So the rest of the period, you guys got to work on the problems. You should be able to get them done before you leave. So I hope you don't have any homework over the weekend. We're going to do 28 to 36, the evens. 34 can be a bit tricky, so let me know if you're getting stuck on 34. Eventually later I'll tell you how to do it. But go ahead and try those out. Figure those done before you leave. Also remember that today is the last day of the 9 week, so if you do have late work, you get that in ASAP. So if you have questions about that, work together, whatever you want to do, get that finished.